Okay, on my video here, I've set us up for synthetic division. I'm going to use the 0 for the factor x minus c. I can't really actually use synthetic division, just would have to use long division, unless my factor is a linear binomial like this one is, without a leading coefficient. So the leading coefficient of x always has to be 1 in order for this to work. So we're dividing x minus 2 into x cubed plus 4x squared minus 5x minus 14. But to simplify it, we're going to leave the variables out. So we put the 2 over here in a box. That's our divisor, but we're using the opposite of the factor, so it's the 0. And then we do the coefficients, 1, 4, negative 5, negative 14. And if we were missing any terms, like if we had like an x cubed plus x plus 0 plus something, and it just was missing our x squared, then we would have to put a 0 in for that coefficient. I'm sure we'll see examples of that later. In fact, I see one right here that we'll get to look at later. Okay, let's go ahead and do the process on this. So the first thing we do is drop down the 1. I'm going to write arrows to help you follow along, but I don't know, walk right them in your notes, it might make it a little messy. That's okay. And you're going to multiply the 1 times the 2. So 1 times 2 is 2. I'm going to write that here. Now, because I changed the sign from a negative 2 to a positive 2, that takes care of the subtraction step that we did in long division. We don't need to subtract. All we do is add. We don't have to worry about those weird signs. So at this point, all we do is add. 4 plus 2 is 6. We're adding those together, which you didn't realize what was happening. So then you're going to take that and multiply it times 2, which is 12. And then we're going to add those together, and we get 7. And then we multiply 7 times 2, and we get 14. We add those together, and we get 0. So this is our final answer, but without the variable in it. So in order to write it so it's in a form that looks right.
Oh, that's great.
Yeah.
Because you just go down and plug in the variables.
Yes, you just go with the variables in order of exponents, but you always go 1 less than what you started with. Yeah. So since our dividend was x cubed, we start with x squared, and we have a remainder of 0.
That's something.
It really is. There are some, some limitations to it. And it just makes it really powerful to use for helping with factoring. Okay. Any questions on this so far? So I think Dominic discovered that we were doing exactly the same problem that we did on the previous page. And we got exactly the same. Doing it in a different way that was much faster without having to stop and think, oh, I have to change the sign, all that. Okay. Use synthetic division to perform the following polynomial divisions. Find the quotient and remainder. Then write the dividend, quotient, and remainder in the form, oh, see, I knew this was somewhere. P of x equals d of x times q of x plus r of x. So there's a whole different way of writing it, which is also true. I didn't write it wrong on the other page. I just was trying to remember where that was going to show up and why we cared. So basically, we're saying our original polynomial is going to be equal to our divisor times our quotient plus our remainder. Okay. So let's start with this one. What's the 0 we're going to use if we do synthetic division? 3. And then my pen is not happy with me today.
So wait, so if it was adding, would it be negative? Or is it just?
So if it was x plus 3, we would use a negative.
Okay, so it's not.
Exactly. And so then our coefficients are 5, negative 2, 0, and 1. So because there was no linear x term in there, we had to put that 0 in there. The whole hold that place like as if it's a decimal point. All right. We're down to 5. 5 times 3 is 15. Negative 2 plus 15 is 13. 13 times 3 is 39. 39 plus 0 is 39. 39 times 3, when I need a calculator. Yep, good job. And add those together, we get 118. Put an extra 1 in there, I don't know why. So that is the remainder. So if we write this in the form that they're asking us to do it, it would be p of x, our original polynomial, I'm not going to actually write that part out, is equal to d of x, our divisor, times q of x, our quotients, 5x squared plus 13x plus 39. Notice how I didn't write it down without putting those x's in there. And then plus 118. So what if we did polynomial multiplication with x minus 3 and 5x squared plus 13x plus 39, and then we added 118 to it? What would we get? We would get our original polynomial back again, right? Just like we would do with normal division with normal numbers that aren't hidden with variables.
So how come you have combined the 39 plus? You didn't go to the lecture, right?
Okay, so then we have negative 2. There answers that question you were having on the last problem. And we have 1, and 0, and 0, and 8. Why did I put 2 zeros in there? Yeah, we need our x squared, we need our x, and then we have our constant. Bring down the 1. 1 times negative 2 is negative 2. Add 0 and negative 2 is negative 2. Negative 2 times negative 2 is 4. 0 plus 4 is 4. And then 4 times negative 2 is negative 8. So guess what? X plus 2 is a factor of x cubed plus 8. I don't know if you recognize that x cubed plus 8 is actually a sum of cubes. X cubed and 2 cubed. And so we actually have those factors that you learned from the sum of cubes. So p of x is equal to x plus 2 times x squared minus 2x plus 4, remainder 0. So I'm not even going to add that. So we just use synthetic division to prove the formula for the formula, kind of a formula, for factoring a sum of cubes. That is what you learn, is the factoring a sum of cubes. That's pretty cool. Okay, now this one is a little bit complicated because we have 2x minus 3 that we're dividing by, and we can't have a number there. So we're going to factor out 2, which would make that 3 halves. But that means that 2 doesn't just go away. We have to remember that that 2 exists, even if we just are using the 3 halves to divide by. So let's go ahead and put this in a better order. So we can use 3 halves for our synthetic division, right? And then I want these to be in order. So negative 12x squared minus 8x plus 4. Oh, when I do synthetic, I don't usually include those, huh? I kind of just feel like I need to rewrite the whole problem. Sorry. Maybe you've already written stuff. It's okay. I have less room. So negative 12x squared minus 8x plus 4. Then in the denominator, I'm going to take out that 2. So I have x minus 3 halves. What do you notice about all of the numbers in the numerator? They're all even. It doesn't look like 2. So honestly, we could factor 2 out of that right now so that we don't have to worry about it later. So then the 2's can cancel. And now we have a different problem, just with those 2's kind of factored out. Sorry, I started writing that in a confusing way. Does that make more sense? Do you see what I've done? So if they were not all even, if some of them were odd and it wasn't that easy to just divide out that 2, then you would just have to remember that that 2 has to be divided out at the end in your answer to have fractions. Okay, I want to make sure I have enough room to do this problem, so I'm going to drop my screen down. I hear erasing. I'm really sorry that I started writing that out later. Okay, negative 6, I left the x off of my 4, oops, minus 4, positive 2, I don't need to do the positive, okay, we'll do first. Drop the negative 6. So negative 6 times 3 is negative 18 divided by 2 is negative 9. Did I do that right? Then negative 4 and negative 9 is negative 13. And negative 13 times 3 is negative 39 halves. Of fractions. Sorry, I have to remember how good attitude about fractions. Fractions are our friends. So we have 4 halves minus 39 halves equals negative 35 halves. So there's my work for the fraction. Did I lose anyone in my fraction subtraction? I just had to get that common denominator, right? So then this one would be p of x equals x minus 2/3, or 3 halves, sorry, times negative 6x minus 13 plus our remainder, but it's a negative remainder, so I'm just going to put a minus. So there's an answer with a bunch of fractions in it. If we didn't want all those fractions, we could honestly just go back to the original problem and multiply everything by 2. Okay. Okay. Let's pause and process this video. Take a little break if you need to stand, stretch, whatever.